So, today we're going to talk about prime factorization. Any idea what that means? Oh, okay, good. Sounds like everybody knows what it means. No? Alright. So I guess we're going to learn something today, huh? Prime factorization. So, we're going to talk about two groups of numbers again. I think we introduced this or said this the other day. We have prime numbers and composite numbers. Remember that? What were prime numbers? Okay, well, how could you explain them? Exactly right. The factors of prime numbers are only one and a self. So, some common prime numbers: 2, 7, 11, 3, 5. Okay, that's a good one.
17, 2.
This is a good one thinking about. 2, 17. Okay, so there's a lot of them, right? So then what's the other group of numbers? Composite. And so they got at least more than 2. Okay, so Colbeck, when we were talking about prime numbers, said 1. What do you think? By definition, it really is, right? But if you think about the definition, it's 1 and itself would be 1. So it's really only it's only got one factor, and that's 1, right? So here's the big star. 0 and 1 are neither prime nor composite. Yeah? Make sense? So again, we've kind of talked about that more the other day. So this leads us to talking about the subject again, prime factorization. And what this means is we are going to write the factors of any number in terms of prime numbers. So again, when we talked about the factors of a number, the factors of a number were simply what? What were the factors of any number? The numbers that did what to each other?
That could multiply to get the number that you're looking for.
Exactly right. So now we are going to write them in terms of prime numbers. Okay? So every single answer at the end should only be prime numbers. But when you do this now, you can have or include exponents in your answer. So this is kind of opposite of what we said yesterday, because we said anytime that there was a number with exponents, we should simplify it. Well, today's kind of the exception. And this is the only reason that it's an exception is because we're doing a specific, what do I want to say? Can't think of the word I want. Anyway, so how are we going to do this? We're going to use a factor tree. Have you ever heard of a factor tree?
Yeah.
What's a factor tree?
Like all the factors go continue. I remember exactly.
Okay.
I remember doing it.
I remember doing it, yeah.
I remember
you
doing
number
it.
at the top and then you do like
Yeah.
2 and the other number and then
You
you
just
go
keep
down
going
further
down.
Perfect. Okay, so I'm going to use a factor tree. I'm going to pick any two or pick a group of factors for that specific number. And again, we can do this now with numbers or with monomials. We'll get to the monomials here in just a little bit. But we're going to pick a group of factors, and then you're going to keep breaking them down until you have nothing but prime numbers. So, if you compare your answer with somebody else in class, or you look in the back of the book maybe to get some help, yours might not your tree might not look exactly the same, but it's still going to end up with the same numbers at the very end. All right? So for an example of like 72, we could have multiple groups of factors at the beginning, couldn't we? What are factors of 72 that work? 2 and what?
36.
2 and 36. 8 and 9. What else? 3 and I think 24. Okay, so we'd have a bunch of those, and we're going to use any which one that we want. All right, so that's what we're going to do. And it's a tree because we're going to try to break it down into its kind of limits. So let's just do 72. So if 72 is at the top, okay, somebody pick one group of 8 times 9. Okay, so I'm going to list the factors. And again, it doesn't matter which ones that you pick, we're going to eventually get to the same answer. So then when you branch it off, you got to decide, are those two numbers prime numbers? No. So if they aren't prime numbers, you have to branch them off again. So what are the factors of 8? 2 times 4, right? Now again, when you do these factors, don't ever use 1 in the number. Because basically you're just listing that number again and it's not getting broken down any, right? So it's kind of pointless. Alright, so how about 2? Is that prime?
Yes.
Yes. When I get to a prime number, I like to circle it. You don't have to do this, but just so I know that I've already got to it and I'm not going to lose it at the end. Can I break 4 down?
Yes.
2? What? 2 times 2. And again, I'm going to circle those. And then I come back over to my 9, and is that prime? No, and I can break it down to what? 3 times 3. Now, can I break down 3s? No. So whatever's left over is going to be my prime factorization. So I have 2, and I'm going to use 2 as my base, but how many 2's do I have? 3. So my 3 is my exponent times what?
Times 3 to the second.
3 to the second. And that is my prime factorization. So if Alex would have done his 2 times 36, he would have eventually gotten to the exact same thing, just in a different way. All right? So not too horribly hard, hopefully. So let's try number 50. First things first, we just need a group of factors. 2 times 25. You're going to do what, Alex?
I'm going to do 10 and 5.
10 and 5. All right. So we're going to do both of them. Just to prove that it doesn't matter how you do it. Okay? So if we do the left-hand side, one first, is 2 a prime number? Hope so, because it was in the last one. And then 25 can get broken down into 5 and 5. And again, both prime numbers. So my answer here for my prime factorization would be what?
2 times 5 squared.
Perfect. Okay? Now if I come over here, now I already have my 5, and then my 10 can get broken down into what? 2 times 5. And so at the end, look, I get the exact same thing that we got going from the other number. So again, it does not ever matter what numbers you look into. Okay? Try by yourself 200. See what you get. Should have done this one tomorrow in church. Remember, keep going and going and going until you get all prime numbers in the bottom. And then we're going to write it as a product, right? All right.
Yep.
Anybody else use 10 and 20? What else did you use? 8 and 25? 4 and 50? 2 and 100? Right? Well, we all got the same thing, didn't we? Okay? So, then, because now that we're in algebra, this maybe was something that you've done before. Because you said you remember drawing the tree. Well, now we're going to try to do the same thing, but with monomials. So, what are monomials again?
Something that is not separated by
Okay. What else?
Their term.
They're terms, right? And so what did we say was a term?
Product, variable, or number.
Exactly right. Okay, so when we talk about monomials, now we're going to include variables sometimes, okay? So when you do these parts, one of the things that you have to remember, and maybe even over here with the numbers, all right? But especially with monomials, if there is a negative sign in front of whatever monomial you're talking about, you need to list -1 as a factor. So from here on out, if there's a negative sign in front of whatever we're talking about, you got to make sure that you put that as one of your factors. And then, because it's a monomial, it could be a product, like Addison said. So if it's a product, it could include numbers and variables. So when you do the variables, you're going to list each variable separately. Okay, so this includes anything that was with or in an exponent like we did yesterday. So they just want you to show all of the letters that are involved. So if, for example, if I had x cubed, I would need to write it as x times x times x. Okay. Now, realistically, they tell you that they don't want you to use exponents in this, even with your numbers. But I'm okay with it if you use exponents in your numbers. Instead of writing out 2 times 2 times 2, you can write 2 cubed. But if it's a variable, you got to write them all out. So if there's multiple variables, you have to do that.
Does it have to be -1?
What do you mean?
With a monomial, does -1 have to be a factor?
No. Only if the original problem was negative. Okay? Good question. So let's look at a couple of these. So if it has a coefficient in front of the variables or it has a number involved in the product, you do the numbers just like we did over there. Okay? So 16 p squared q to the 4th. Okay, so we're going to do 16 just like we did over here. And then we're going to do the letters by just writing them out in a list, showing them as a product. Okay, so 16, 4 and 4. 4s break into 2 and 2 and 2 and 2. So we have 2 what? To the 4th. Is that right? 2 times 2 times 2 times 2 gets us back to 16. And then we're going to break it down. So times, how many p's do I have? 2. I need them. And then I have 4 q's. So I'm just going to write them all out. And my answer here for my monomial then is the same thing that we did. We just now do it with the letters too. Make sense? So one last one. So this is the one that we're talking about here. You know, if we had negative 48 j squared k cubed. Try that one by yourself. So again, we're just writing it out. As much as we possibly can. Ran myself out of room. So again, how'd I do? 2 to the 4th times 3, and then 2 j's, 3 k's, and don't forget that -1. So again, don't get going too fast that you forget that -1 when the original problem has a negative.
It doesn't matter what the -1 is in the problem, does it?
No. But again, I would always put things either in chronological order, meaning smallest to biggest with my numbers as my bases, and then alphabetical order with my letters. But again, you don't necessarily have to do that. Okay? Questions there? That's it for today. That's all you gotta do. Piece of cake, right? All right. So you got about